One thing we haven't talked about so far is man-in-the-middling the emulator, and this might be required for you right now. So you do not need a real device to perform this course over here, and therefore you might want to know how you perform the setup for an emulator, because we've got some tasks to do in our man-in-the-middle setup or in our man-in-the-middle challenges, and therefore we need to know how to perform this. Alrighty? Okay. The reason why we haven't talked about so far is I'm really not a big fan of the setup. So if you want to analyze a mobile application, then take your real device. Set up your network connection via the network manager, provide DHCP and DNS automatically via the shared connection, hook it up to your access point, and you're good to go. You see every single network package the smartphone is making. Regarding to the emulator, we have to rely on software, which means we have to rely on certain operating systems regarding to the virtualization, and this can cause trouble. So therefore, yeah, I'm not a big fan of the setup. Nevertheless, you can do every single challenge in this course over here with the emulator also. You do not need to buy a real device. You can do this all on the emulator, okay? There's absolutely no problem. And also regarding to pen testing real-world applications, I would claim 90% of all applications can be analyzed with the emulator. In case if you're analyzing IoT stuff with Bluetooth, NFC, or maybe other strange protocols, then I really recommend using a real device. Okay, but for now, let's say no real device available. We have thrown it into the water. All right, how can we do this? Let's have a look. Let's switch back to the Ubuntu VM and let's figure this out. Okay, so here we are back at the Ubuntu VM, and the first thing I would like to show is the emulator bug, which is still out there right now. So I have already described this in the tools, and if you heard this now twice, then sorry for this, but if people jump directly into this man-in-the-middle on topic over here without going through the installation part, then this might catch you right now. Okay, so what's the problem? If we want to start our emulator, we've got, I guess, two options. The first one is by the Android Studio. So let's have a look. In tools, bin, Android Studio, bin, and then bash studio.sh. This is the approach I'm normally not taking, because we're now starting Android Studio to just start another tool which could be directly started. So why go this way? But nevertheless, within the Android Studio, the debug output is a little bit better than on the terminal just for the emulator. So sometimes it's handy. Okay, within configure, if you're not having a project selected, we've got AVD Manager, which is the Android Virtual Device Manager. And here I'm having now a Nexus 6 RP30. So it's Android 11 RP30. And here we can see CPU architecture x86. The Android Studio also has the ability to emulate ARM devices. ARM is the CPU architecture for those smartphones, those native smartphones over here, not those fake ones we are using right now. So this one is a little bit slower. Okay, it's not a little bit, it's way slower because it needs to be emulated on an x86 architecture. If we are emulating an x86 within an x86, this is way faster. But we could also run into problems on certain applications, which has been exclusively designed to work on real devices. If you want to know more about this topic, I have made a whole video about the difference between x86 and ARM, why we are having this, and how this all plays together right now. Okay? All right. We can see the smartphone is requiring 8.1 GB of disk space, and we could simply start this emulator via this button over here. I highly recommend you using a Nexus 6 device, because if you are using a Pixel device, this is way faster than the Nexus 6 and requires also more resources. So within the emulator, we do not want to have a power device. We want to have a really low level device which acts just like a smartphone and does not have all these fancy features, because those fancy features require resources of our system, and this smartphone would be terribly slow. Okay, so that's how we can start this emulator via the Android Studio. But as already mentioned, there's an easier way. And the easier way is using the emulator. So if you type in emulator, then we are using the Android emulator, which comes with the SDK. So if we are performing which emulator, here we're having now the binary that's being executed. And this binary has been also added to our path variable. So this directory, this tools directory, let's see. There we have it. Okay. This means if you're running emulator, the terminal is looking into all those directories and searching for an emulator binary and executes it. Okay. Okay, so now where's the problem? Well, let's try starting our emulator, and we have two options: add with the name or -avd with the name once again. So I'm not sure what's the name of my emulator, so I'm using emulator list avds, and here we have it. And now we can use emulator, add, and then the name. And now we're getting missing emulator engine program for x86 CPU. And the problem is that the emulator binary within the Android SDK has been placed into tools, is outdated. So we are having now two emulator binaries, one within tools and one within emulator. And if we're having both in our path variable, we do not know which one gets picked. And you know what? It's always the wrong one. So therefore, what we need to do is we need to get rid of this emulator binary, and then we have to include it over here, the emulator directory in the path, and then we are good to go. Okay, so maybe let's do this a little bit graphically that you see what's going on, because it's not that easy to follow on a terminal. Okay, so here we're having tools, the emulator binary. We could delete this right now because that's the outdated version which shouldn't be used anymore, but I'm not a fan of this, so let's rename this. If we are renaming it to emulator.bug, and also this one, then if you're now using emulator, oh yeah, it would work because it has been added to the path. Never mind. Okay, if we rename this to bug, we are only having one emulator binary right now in our path variable, and this one is within the emulator. So the file structure has been changed in the last couple of years within the Android system, and it still gets messed up. So this one is the emulator binary we need to execute. And this one is located in Android SDK emulator. Okay? They are named identical, and both tools and also this emulator directory needs to be included into the path variable. If we are throwing out this tools directory, then we lose access to Android, make SD card monitor, and things like this. Maybe these are also outdated binaries, but for now the only problem we are having is two binaries in different versions with the exact same name. So therefore let's get rid of one of them, and then we are good to go. Alright, now let's see. Yes, if we are now simply running the same command once again, it should work, because then it's going into the path variable, or yes, in the path variable, it looks it up and sees, okay, within the SDK emulator, I've got an emulator binary, I'm using this one. Let's verify this. Which emulator? Here's the ultimate proof that I'm, a little bit silly and made this mistake over here, but it doesn't matter. It can still be executed. So within Android SDK emulator is now the emulator binary, and here before it was within SDK tools emulator, because this was the first one which has been found. I would like to fix this real quick. And then we go to the man in the middle setup. Yes, and this error, it cost me quite a while to figure out, and therefore I would like to include it in a 3-minute breakup over here, that you do not have to search 15 to solve this right now. Okay, so now we can start our emulator finally. Let's go, let's do this. Yes, now we can see the emulator version 33, and here we get the next warning in this case. Running a virtual machine within another virtual machine is something we have also discovered, or talked about in the installation part. It's not a good idea. If you are using newer devices, a Pixel device, then the user experience would be absolutely horrible. In this case right now, it doesn't require that much resources. So I'm not having a full power PC. I'm using 8 GB of RAM and I guess 2 CPU cores. This is pretty standard nowadays. So therefore it should also work pretty smoothless. I highly recommend you doing this all on your host system to get up a separate laptop to perform your penetration testing, reverse engineering, and analyzing. So within this setup on your host desktop, you can run this emulator pretty fast. So that's amazing. So you do not see any millisecond of lag in there. Right now we might have a little bit, but it's still good to go, and this is something I would like to prove over here. Okay, so let's start this one. Yes, and there's still this old application, the insecure bank, opened. Okay, so let's close this. Alright, so now we're having this device, and this device has an Wi-Fi access maybe? No, not now. But it also claims to have a mobile network access. And of course, those networks are virtualized. So this emulator does not have a SIM card with a phone number in there. And it also has no no physical Wi-Fi access. So these network connections are just virtualized and they are being taken from the system over here where the emulator gets started from. So now if you also want to forward internet access to this device, we need to make sure that our host system has internet access. So therefore I enable it. So let's make the connection. Okay, now we've got internet access on our virtual machine, and then we will see internet access appears in 1 or 2 minutes also on our smartphone right now. I guess if we are now opening the web browser, it should be already there. So let's see. Oh, that's nice. There is no web browser on this device here. That's interesting. Well, okay, then let's choose WebView. So WebView is simply just an application which performs in WebView. So we are having a little in-app browser in there right now. Okay, so let's see. HTTP example.org. Okay, yes, we can see it's working. So, I mean, we do not require a browser in there because all the network traffic we want to man in the middle are regarding to our mobile applications. So therefore, we are absolutely fine with this low-level device right now. Alrighty? Okay. So performing this man in the middle setup right now, we have, generally speaking, I would say 2 options regarding to the emulator. One is something I really cannot recommend, but I still want to show you why and how. So the first one, which is always referenced, is using the Wi-Fi settings as a proxy. If we go into settings and then network and internet, on Wi-Fi, so you can see it's a little bit laggy, but I guess it's still fine to work with this device. Then we have to wait until our emulated Wi-Fi appears. By the way, we're having internet connection, but still this X at this point right now. So this is a perfect example because the emulator is now using the virtualized mobile connection instead of the virtualized Wi-Fi connection, which means if we're inserting in here in those settings our burp suite proxy, this wouldn't do anything right now. Let me show this to you. So let's start our burp suite. Here we have it. And now we do not have to make a complex setup with IP table rules and things like this because we only insert the values of the burp suite as a proxy into this one over here. So this is how many man-in-the-middle setups are now being referenced, and it's not a good idea, and you will see now why. So let's choose temporary project, use burp defaults. Okay, and then within proxy, options. So if we click edit, specific address, we can see we are not having our 10.42.01 interface up right now because we are not having a physical network interface where we want to connect to right now. Therefore, the easiest way is using all, or we could also simply just select this one over here because that's the interface of our Ubuntu VM network card. So this one. The smartphone can connect to this interface and we can forward the traffic from this interface into the real world. Okay? So yeah, you could select all or simply just your interface over here. Regarding to request handling, we have to apply invisible proxy. Okay, and now we're good to go. Okay, so now we want to insert it as a proxy. Therefore, we have to go to this pencil and Wi-Fi options. And here we also have some confusing options, treated as metered, treated as unmetered. So yes, we already have decisions. And decisions regarding to the network traffic are always bad because if we do it this way, then we might miss the other part and vice versa. All right? Okay, let's say we treat it as unmetered and now proxy, manual, and now let's go. The host name is HTTP 172.16.214.129. It's exactly this one over here. Yes, and now the port is 8080. We do not want to bypass, and yeah, DHCP. So why can we not save it right now? Oh, we have to get rid of this one. Okay, Now we can save this. And now let's see. Okay, let's try if our burp suite can man in the middle this request, because we are still talking about HTTP. There should be no problem regarding to this one. To be fair, this might have been already cached. So therefore we are not using .org, we are using .com. Okay, so I see nothing inside here right now. And we can see the smartphone is browsing. Maybe I have made a wrong configuration, so therefore let's go back. Okay, and let's switch to the other part. So instead of treat it as unmetered, let's select metered. Let's do this once again. And now we can see we have lost the Wi-Fi part. So let's see, HTTP example.com. Nothing here. Let's do it for example.org. Still nothing here. Let's do it for google.com. Even if it's HTTPS, we should see some errors. Nothing inside the burp suite. Okay, so I guess it's not working in this way. Last but not least, we've got this automatic option, but I guess we get this point. Doing this in this way, it's not really reliable to fetch anything. Also, the problem is that some applications can detect proxy settings like this. They can say if the smartphone is using certain proxy settings, then do not make this request. So please do not use it in this way. Let's get rid of this one right now. So we do not want to do this. All right, so we have seen it flips between Wi-Fi and virtualized mobile connection, vice versa, and sometimes it works, sometimes you miss some stuff. Not a good idea. What else can we do? The easier option is using the global system proxy for this whole device, and we can find this within the 3 dots. So here we can see if we select manual proxy configuration and select our burp suite, then we can hit apply, okay. And now we're having a more global option. I wouldn't rely on that this man-in-the-middle setup is now fetching every single network packet. So regarding to UDP or other stuff, it might be still tricky. But now we can already see this device is making some requests. So these requests are being forwarded into the burp suite. So it will at least fetch all those basic network packages, which is fair enough for 90% of all applications. All right? Within this course, you have absolutely no bad experience, or you do not miss anything if you are performing it via this way. Just keep in mind, for real-world applications, especially on IoT applications, please use a real device, like this one over here. Alrighty? Okay. Cool, so now we can see that's all we need to do. Forget about the first part. You have seen why it's bad. Now it's flipping between those two connection types, but we do not care because we are fetching the whole network traffic. Not the whole maybe, but most of the network traffic, through our burp suite. All right, the only thing we need to do, because if you're opening the web view once again, so let's go to an HTTP page. And let's also keep this HTTP history up here. All right. Okay, so now over here, for example, let's see, HTTP example.org. Yes, here we have now this example.org page. Perfect. So we can see this whole network traffic for this application right now with our burp suite. Okay, that's the way better setup right now. Cool. The only problem we are having right now is regarding to HTTPS example.com, in case it has been cached. Let's see what's happening. Okay, let's clear this cache. I mean, it can be done easily here. And yes, we are getting some dashboard errors over here. So let's say there's an error and it claims that example.com received Fatal certificate may be unknown. Yes, it looks like yes. So the certificate is unknown. We need to install the burp certificate also on this device right now. On this one over here. Is that a big deal? Absolutely not. So what we need to do is we go into proxy, options, import export CA certificate. We select certificate dir format. Then we select our home directory and we provide a name like emulator burp.crt this time. So not dir, crt. Okay. And then we are using adb push on the, what was it? I don't know anymore. grep-i crt emulator burp this way. adb push emulator burp onto the SD card, and now we simply need to install it. So if we go back, maybe we can close those applications, then we do not have to care about caching. So settings, and then let's see, security, and then encryption and credentials, installer certificate, CA certificate, install anyway. Okay, the SD card is being loaded. Let's see what view we got. Okay, then on those 3 lines, and we have to select, yes, if we select SD card, we are only seeing those directories, not those files. So we need to go back into Android SD card build for x86, and now we're having also those files. And here we can see we've gotten an emulator burp CRT. So we click on this, and then there should be a success message, even if it's a little bit laggy right now. CA certificate installed. That's all we need to do. We need to go into those settings. We apply our burp suite. Within the burp suite, we need to select the proxy settings on this interface, 8080, invisible, install the certificate, and we're good to go. Really? Let's figure this out. So within the HTTP history, yes, I mean, no, that's still Google, interesting. So let's see. We are opening this amazing web view test once again. Okay, and now we want to go to an HTTPS site. So let's open https example.com. And perfect. We can see https example.com. Here's the network package, and here we can see it's working. So the burp suite certificate has been trusted. All right. This is how we can perform a man-in-the-middle setup on an emulator. Yes, it's way easier, but we are missing a little bit of packages regarding to strange or uncommon protocols. Alrighty, perfect. Have some fun with this, and then I'm looking forward to see you in the next video.